Hi guys, video number 2 of the review package. Progression skills for grade 11 math. This one, we're going to jump around a bit. I'll tell you in a second. I'll do this one in red, so just in case you're watching this. And this is a red video compared to the purple one that we just did. Okay, so first up, we want to look at linear equations. They make straight lines. It's grade 9 stuff for you. And this is slope-intercept form. So what you have here is the slope here in front of the x, and then you have the intercept here. So for example, y equals, I don't know what that is, 6x minus 7. Your slope is 6. Your intercept is negative 7. And I'll show you how to graph that in B. But that's a line that looks like that. And if you need to go on to Desmos for practice, go nuts. This guy here is with a negative means that it's going down. If it had a positive here like 6x, it would go up. Remember, the bigger the number, the steeper the line. So a big positive number is steeper than so this could have a slope of 5. This might have a slope of 2. If we had negative 2, it would be something like that, and negative 5 would be even steeper down. And then a fraction, which is less than 2, so let's say a half, would be even flatter, something like that. And this would be like that if it was negative 1/2. So we'll get to that in a second. And if you're going to graph, you can use a table of values. So to do that, what you do is you take a certain number of x values, and this is quite a bit, 6. But let's say we just started here. Let's say we just did these 3. What you're going to do is you're going to sub negative 1 into this equation, and when you do that, you get negative 1 times, or sorry, 2 times negative 1. So the x is negative 1 in this case. So you write negative 1 here, and then you sub in negative 1 there. So that's 2, not negative 2, times negative 1, subtract 5, and that will get you negative 2 subtract 5, which is negative 7, and that's where this comes from. And you do the same for, you sub in a 0, and then you get negative 5, and then you sub in a 1 here, and you get negative 3. So you do this 3 different times. And then you get your 3 points, and 3 points is probably the safest way to do it, because that way, if the 3 points line up, and you can connect them with a straight line, which kind of did there, then you're probably in good shape. So what you'll do is you go negative 1, negative 7. So negative 1, go over 1, and then down to negative 7. And then 0, negative 5, and then 1, so over 1, and then down negative 3. And notice how those three points are in a straight line, which means you probably didn't make a mistake. And then you connect the dots with a straight line, and then don't forget to put arrows on the ends of the line. This one here has a slope of 1/2 and an intercept of 3. So we're going to graph this that way, just using the slope and the intercept. So the intercept is 3, so that's right here. A slope of 2, let's say we had a slope of, let's make it 5. A slope of 5 would mean that you would go from one point to the next. This is, remember this is your rise and your run, okay? So, or delta y over delta x, change in y over change in x. Maybe you learned it that way. And what that means is if you had a slope of 5, what you would do, so let's say I had a slope of 5, I would go up 5, 1, 2, 3, 4, 5 for each one that I go over. Okay, so I would have a line that would look something like this, go straight up and down like that. Not straight up and down, very steep. When you have a fraction like this, it's even easier. You're going to go over, rise is up, so up and down and side to side. You're going to go up 1, okay, and then you're going to go over 2. And then draw this point here, and then connect these 2 points in a line. So if you had other lines, let's say we had negative 1/2, what you're going to want to do is, let me see if I can get rid of this. What you're going to want to do is, if this was negative 1/2, was my slope, so negative 1/2 x plus 3. So I'm still here. I would go, this negative means go down 1, okay, and then over 2. So the negative means go down. Some people like to go left. I wouldn't bother. And then you would connect. It would look something like that. Okay. So that is graphing like that. If you want to find the intercepts, what you do is to find the x-intercept, you set y equal to 0. And to find the y-intercept, you set x equals 0. So here I have an equation that looks like this. It's in standard form or close to standard form. and it's not in y equals mx plus b form. So what you do is you set, so here you're going to set x equal to 0, and this will get you the y-intercept. So to get the y-intercept, you set x equal to 0, and to get the x-intercept, you set, this is as set y equal to 0. So you set x equal to 0 in this equation, so you have 2 times 0, because x is 0, subtract 3 times y equals 6, and then that is 0, so it disappears, and negative 3y equals 6, divide by negative 3, you get negative y equals negative 2. So this is the point here, x equals 0, y is negative 2, or my y-intercept is negative 2, it's the same thing, and that is that point down there, down to negative 2. This one here, to get the x-intercept, you set y equal to 0. So you set y equal to 0 into this equation. So it's 3 times 0, bye-bye, because it's 0, right? Right? Anything times 0 is 0, and then you have 2x is equal to 6, x equals 3. Your second point is the point 30, which is right here, or that is your x-intercept. Remember, this is the x-axis, this is the y-axis. So that's how you do that. I'm going to skip the next part until after we factor. So, no, no, not the next part. Sorry, the next part. So let's look at what do you call parabolas? There's an x squared involved. We have a parabola. This is in vertex form. So what you have is your vertex, and where is it? Right here. So y equals ax minus h all squared plus k. Your vertex is hk. So what you do is you look in the bracket and say, what's my vertex? I change the sign of what's in the bracket as my x value. So you have x, y of the vertex is h and k. Okay, so h and k is your vertex. So here in this bracket, change the sign to negative 4 from plus 4, and then you say what's outside the bracket. In this case, nothing. So it's 0. So my vertex is the point negative 4, 0. So I go over to negative 4, 0, and I plot that point. Remember the step pattern. The way the step pattern works is it's a, or this number, times 1, 3, and then 5. I'm not going to bother with all 3 points. I'm just going to do 2 points. So what you do is you go 2 times 1, and then 3. 2 times 1 is 2. So my first step is over 1, up 2. Okay, and I plot that point, and then my next point is 2 times 3 is 6. From this point, I go over 1, up 1, 2, 3, 4, 5, 6, and I plot that point there. So I have the vertex, I have this point, and I connect, sorry, before I do that, there's symmetry, obviously, in a parabola. I don't know if that's obvious, I should have said that, but there's symmetry in a parabola. So the points across here are symmetrical. So this is to the right one, up 2, this is to the left one, up 2. So you just draw the mirrored points, and now you connect the dots. Now, my thing that I draw on is a little slippery, so my parabola looks a little bit wonky. Okay, but that's what that looks like. This one here, my vertex, changed the sign, and then outside is 5, so plus 7, plus 5, that's the vertex, 7, 5. And then my step pattern is going to be negative 1/2 times 1, 3, 5. So negative 1/2 times a half, or times 1 is negative 1/2. Negative 1/2 times 3 is negative 3/2. So that means go over 1. Okay, so this is where it gets, so you're still going to go over 1 and then down. Here, this says go down 1/2. And the reason you go down 1/2 is because it's negative. Okay, so this guy's going to open down. So this vertex here is the top or the maximum. Remember we talked about max and min and all that last year? I know you did. So you're going to go over 1, down 1/2, and then over 1, down 3/2. That's how you get your points. So negative says go down, and then the mirrored points are here, and connect those there. You don't need the 5th point. Just connect. You have 1, or sorry, you have 1, 2, 3. You don't need that 3rd point, the 1, 3, 5, because once you have 1, 2, 3, you have 4, 5. You have 5 points. You don't need the 7 points. Okay, so connect the dots, and you have that parabola that looks like that. Okay, so this is what I was going to skip until we factor a bit. So I'm going to factor, and then I'm going to come back to this. Okay, so quickly, factoring. Common factoring, is there a number and a variable that goes into 2 terms? So for example, I'll I'll skip this one here and say, is there a number that goes into 12x squared and both 12x squared and 8x cubed? Yeah, there is. 4 goes into 12 and it goes into 8. So that's how I get this. And then I say, is there a variable that I can go into this? Or what's the biggest variable I can take out? X squared, x cubed, I can get an x squared out of both of them. And when I divide this by 4x squared, or I can ask myself, if I had 4x squared here, what would I have to multiply that by to get 12x squared? And that would be 3. Okay, so 4 times 3 is 12. I already have my x squared, so I'm good. This one here, I'm going to say 8 divided by 4 is going to leave me the 2, and I still need another x, so I put an x there. So that is factored. When you get something crazy like this, you just go through each term here, and you could say to yourself, what's the biggest number that I can get out of -6 and 18? And the lowest or the greatest common factor between the two is -6. So you want to take the negative out if you can. Okay, so if there's a number, like if you're asking yourself, should this be 6? The answer would be, it could be, but we'd like to take the negative out. So we're going to divide by the -6. Okay, and then you say to yourself, how many A's are in both terms? There's just the one, so I can get that out. Is there a B in the second term? Nope, so I can't get a B out. So that's not going to come out. And then I have C squared here. I have C to the 4 here, so I can get C squared out of both. And when I do that, I'm left with B cubed here. Okay, so I have all the A's are gone, all the C's are gone, but I need those 3 B's, so B cubed. Here, I divided by -6. That leaves me -3 as my constant. Okay, here when I divided by -6, I had just a 1 here, but I'm not going to write that. And then I have 1 A is out. I need 4 more, A to the 4 here. And I had 2 C's are gone, so I need C squared here. And when you multiply this out, that's how you know you're right. When you multiply it out, you end up with the original. Difference of squares is going to be, got a little excited there. Difference of squares is going to be something where you have 2 terms, and the first term is a perfect square, and the second term is a perfect square, and they're separated by a minus sign. So here I have x squared and -36, so 2 terms, negative. The root of x squared is x, the root of 36 is 6, and then that's what you end up doing is you write it as the first term plus the root of the first term plus the root of the second term times the root of the first term, subtract the root of the second term. Okay, so x plus 6 minus 6. Okay, so I might have confused you a little bit there, but that is the root of x squared is x, the root of 36 is 6, and then plus and minus. So here, what's the root of 9x squared? So here I have 2 terms. Okay, both potentially perfect squares, and then with a negative between them, so I can get a different square. So the root of 9x squared is 3x, so I write 3x here, and the root of 25y squared, well, the root of 25 is 5, and what is the root of y, what is the root of y squared? What times itself gets you y squared, and that's y. So that's 5y is the root of of 25y squared. So I write plus 5y minus 5y. Difference of squares, you want to have the different thing here. We go back to the earlier video, and what happens is when you expand these, so if you go back, if I can find it here, go back to this video here, when you expand a difference of squares like this here, what ends up happening is these 2 terms negate each other, cancel each other. Okay, so when you multiply, you can have a 2 terms same size but different sign, and they'll cancel each other out. So I'm running out of time here. So let me see if I can get one last question before I make a third video. Simple trinomial was yes. So I want 2 numbers that multiply to 12 and add to 7. So you got to watch your signs here, right? So if this is a plus and a plus, both these are going to be plus. Okay. Just be careful when you do these. They multiply to 18 and add to 11. Now here, so I like to keep track of this plus and a plus. In the bracket, you can have a plus and a plus. That should be a plus and a plus. If you have a minus and a plus, here they multiply to 18. 2 numbers that multiply to 18, but they add to a negative. So you know what? I'm going to pause this here and pick up. I'm almost out of time, so I'm going to pause this and we'll finish up with the third video.